I have number 1. All right, so we're graphing quadratic inequalities. What I want to be able to look at here again is to just revisit what does it mean for graphing inequalities. So if you're graphing an inequality and it is a less than or a greater than, what does your line look like?
It's going to be dotted.
It's dotted. If it's less than or greater than or equal to or less than or equal to, it is going to be
Solid.
We've done that before. That rule does not change. What's going to change a little bit now is how it looks. I've got 4 different types of problems we're going to be working with today. The first one is graphing with 2 variables. Basically, this just means you have a y and an x. And if you graph something like this before, if we graph the equation y is less than 2x minus 3, if you had to graph that linear, what would you start with? You'd start at -3, and then what?
And then go up 2.
Up 2 over 1? And so on. Would that be a solid or a dotted line?
No, it's dotted.
That would be a dotted line. And then after that, you would find a test point. What was the easiest test point in the world to use?
0.
Is 0 smaller than -3?
Yes.
No.
It is false here, which means it's true here. So what side do you shade on? We always shade towards the truth. What changes with parabolas?
Now it's like this.
They're either up like a cup or down like a frown.
Yeah.
The rules are the same. You still start by creating your graph. And when we go to graph parabolas, there's only 2 things that I'm requiring that you show on your graphs. Vertex, zeros. Your calculator will find both of them. In this instance here, is this factorable? What times what's -3 add together to get -2?
Yeah.
Yeah, I could factor that as x minus 1 and x minus 3 and x plus 1. I could factor that. That tells me if I go to rough sketch my graph, where are my zeros? 3 and -1, very good. What occurs at the halfway point of the zeros? The vertex, the axis of symmetry. What is that x value for your axis of symmetry in this case? 1. I know that my axis of symmetry is going to be at 1. Oops. It's always the halfway point of the zeros. Or, wasn't this written in standard form? ax squared plus bx plus c. Your axis of symmetry is always x equals the opposite of b over 2a. Always. Yes, sir? Careful. What's the opposite of -2? 2. What's 2 divided by 2? 1. So I know that my x component of my vertex is 1. I also know that this is going to be up like a cup. Do you agree?
Yeah, x is positive.
X is positive, or a is positive.
positive.
Yeah.
My bad.
So what's 1 squared?
1.
What's 1 minus, 2?
-1.
What's -1 minus 3?
-4.
So my vertex is at 1, -4. About right there. And is this going to be a solid or a dotted line?
It's going to be a dotted, actually. But you don't even have to find any more points.
Nope. Vertex, zeros. Also, if I use my calculator instead of doing that all by hand, what would I have looked for the vertex?
When it starts to be like.
What is that called, that vertex point? What is that? What? It's the minimum. There's no transversal, there's no parallel lines being cut by transversals here.
Oh, that's what it meant. Oh, you just
Guys, remember, the whole,
I love it.
that's the whole idea behind all the work that we were doing. Every time we had a graph or every time we had a problem, I would ask you guys, is it a maximum or is it a minimum? You were able to tell me that. Well, now this is why I was doing that. This is why I kept asking you guys, is that going to be a maximum, is that going to be a minimum? So your calculator could do all this work for you. So now we've gone and graphed our rough graph. What point doesn't this go through?
0.
It doesn't go through origin, does it?
0.
All right. What's 0 squared?
0.
What's 0 minus 0?
0.
What's 0 minus 3?
-3.
Is 0 bigger than -3?
Yes.
So it's shaded inside in here. When you are graphing inequality parabolas, it's either going to be shaded in the cup or out of the cup.
So it's either going to be spilled or filled.
I like that. It's spilled or filled. I like it.
It's about fair. You didn't know?
I thought that was good. You're rolling your eyes. That's not bad. It really isn't that bad, is it?
It's really good.
All right. What changes? Here's number 2. What changes now? Graph 2 of them. Use your calculator. Ladies and gentlemen, when it comes down to the point of graphing 2 of them on the same, when it comes down to the point of graphing 2 of them on the same part, if you're going to use your calculator to find your zeros, find your maximum or your minimum, do them one at a time. And then just share the graph that you're doing by hand. Don't try and do all of it at once because you'll get lost in what it looks like.
Wait,
What I'm saying is just do that first one in your calculator, figure out your maximum or your minimum, find your zeros, plot all of that, and then do the other graph. Don't try and put them all at the same time. People, it gets messy. You tend to mess up what graph you're looking at. Okay? Now, if I'm looking at that first one, I've got y is greater than or equal to x squared minus 4. That's a difference of squares, isn't it?
Yeah.
What are your zeros? 2 and? 2 and -2. I can look at that and I know my zeros are at 2 and -2.
Oh,
Where does your axis of symmetry
you gotta
lie?
add up to 0. 0.
Okay, when x is 0, what's y?
0.
What's 0 squared?
0.
What's 0 minus 4? Really?
Up like a cup.
Is that going to be a solid or a dotted line?
Solid.
Solid. Now, think back when we were shading multiple lines with inequalities earlier. Remember how we just kind of drew arrows to show which way things were going? We're going to do the same thing to get the idea here. Will this one be filled or spilled? Is 0 bigger than -4?
Yeah. I love it.
So I know it's going to be inside the
Fill
parabola.
up my cup. Wow.
Do the exact same thing on the other. When you go through, gentlemen, you do the same thing, but now it gets a little bit messier as you start filling it in. So use your calculator again. Negative x squared minus x plus 2. When I go to graph this, well, I'm going to change my window around here.
Oh, you want to make it closer in?
Yeah. So when I go through that one, there's a couple things you can do. Well, the first thing I want to find is my vertex. Will my vertex be a maximum or a minimum? It's going to be a maximum again. So I hit second trace, number 4 for maximum. Remember, it's going to ask you for the left boundary and the right boundary. So you have to be on the left-hand side of it and the right-hand side. It doesn't have to be symmetrical about the sides, just anywhere. Oops. I did that first.
Yes.
I don't know.
Does it really want you to like make a guess at what you think it's going to do?
Don't know what that means. Yes, sir.
When I typed it in, and I hit graph, it made like a.
And you type something. You have a third degree column.
Then I go and I delete the multiplication thing and have it exactly the same, just adds the multiplication.
Let me look at it in a second. Now, it's giving me a weird decimal of negative 4.99999. What is that?
Negative 4.5.
What's that?
Wait, where are you right now? I'm still here. What do you call it? Can you do second trace?
Second trace, then hit, that's a maximum. Hit maximum, I think it's number 4. And then move your boundaries left and right of the vertex. Okay? So I'm going to say my maximum value is at negative 5, and what was it, 2 1/4? So it's at, the max is negative 0.5 and 2 1/4. Is it 2 1/4 or 2 1/8? 2 1/4. And now I want to calculate my zeros again. When I look at the graph, did you get it okay?
Yeah.
Okay. When I look at the graph, it kind of looks like the zeros go through 1 and -2, doesn't it? Now, you could go right to your table, and when you're looking in your table, when you go in your table, if you get a 0 in your y column, the corresponding x is the 0. If you don't see a 0, that means it's a fractional amount, and you have to use the second calculate button, the second trace, if you will. Okay? Does that make sense?
Yeah.
So here I can find out that I have zeros at -2 and 1. And will that one, when I connect those 3 dots, be solid or dotted? Dotted. It's dotted. So this one was here, here, here.
Dotted like a sprinkle.
Is 0 smaller than 2?
Yeah.
So it's shaded in here. So your area is
It
that.
doesn't work going down though, because otherwise it's gonna spill in.
But the idea is,
Cups submerge with each other.
so you've created like an ellipse-ish figure. Not
It's
true.
almost like the Under Armour symbol.
Yeah, I guess. Okay. Remember, when you are graphing system, just graph them one at a time. Use your calculator to find your maximum or minimum. Use your calculator to find your zeros. Solid or dotted, and which way is it shaded? Yes, sir.
We have to find like the intersection points between those.
Nope. And like I said, using the calculator, this makes life a lot real easy, okay? Now, I've shown you 2 examples that out of the 4 so far, which means we're halfway, right?
Yeah.
These problems all have how many? They all have 2 variables, x and a y coordinate.
Oh no.
Oh no. We're not doing 3 dimensions, but you're winding.
Oh.
There's just one variable in a case like this. And what this is asking us now, if I'm looking at the problem, it says x squared minus 6x plus 5 is less than 0. What that is asking us is the following. Where is the graph below 0? Where is the graph below 0? And since I'm only dealing with my x values, I only have one variable to worry about. If this was a greater than 0, what would it be asking? Where is it above 0? If it was less than or equal to, it would be where is it less than or equal to 0? Things like that. So once again, we start by graphing. My b value is an even number, isn't it? So I can find the axis of symmetry rather without any issues, right?
Yeah.
What's my axis of symmetry for this problem?
3.
3. Opposite of b over 2a. So my axis of symmetry is 3. Do I have to go this route to do this? No. So I know my vertex is going to have the x component of 3. What's 3 squared?
9.
What's 9 minus 18?
Negative 9.
What's negative 9 and 5?
Negative 4.
So my vertex is at 3, negative 4. If I did not want to do that by hand, what could I have pressed in my calculator? Which one is that going to be for find the vertex?
Minimum.
It's going to be a minimum. Remember, and it's a minimum because my a value is okay. Also, next, can I factor that?
Yes.
What are your factored terms?
Negative.
That's factorable. Did I have to factor that?
No.
Could I have used my calculate button again to calculate zeros?
Yes.
Okay. Where are my zeros then?
1 and 5.
1 and 5. Solid or a dotted line to connect them?
Dotted.
Dotted, okay. So, since it's a dotted line, should these dots on the x-axis be solid or open? It should be open, right? These dots here, oops. Let's make it in here just a minute. This should be an open dot because it's a dotted going through it, okay? Does that make sense?
Yeah.
Because it's a less than problem. Now, where is that graph below 0? It's below 0 in here, right? All in here is all below 0?
Yeah.
What values of x is it below 0?
Oh, it's just
1 and 5.
1 and 5. This is below 0 when x is bigger than 1, but smaller than 5. The graph is below 0 between 1 and 5. That's what that question was asking you. Where is the graph below 0? The graph is below 0 between 1 and 5 for the x values. It is not including 1 and 5 because it was a less than problem. That's why they have open dots. And, okay. Does that make sense? And if I wanted to be above 0, I would write it x was greater than 5. X was less than 1. Because that's when it's above, the graph is above 0. In essence, this is kind of like doing the linear programming almost. If we did a linear programming problem, but we throw in y is greater than or equal to 0, or is it, yeah, that means we're going up this way from here. Well, in this case, it's just going this way. Well, it's below it within this parameter here.
Yeah.
It's a linear programming problem-ish with the quadratic. Okay. Now, not all of these things are going to be nice and easily factorable. What happens if they're not? What are you going to do? Use your calculator. For example, I look at this one. I have 2x squared plus 3x minus 3, and it's asking greater than or equal to 0. And that just means, where is this graph above 0? Where is it above? In order to start the problem, I'm going to go right to my calculator. I am not going to try and complete the square. I'm not going to use quadratic. I'm going to look at the visual representation of the graph. I'm going to calculate, is this going to be a maximum or minimum? It's going to be a minimum. And I'm going to calculate my zeros by pressing a whole bunch of buttons. So, y equals 2x squared plus 3x minus 3. Graph it. Make sure your window looks somewhat normal. We're okay. I have a minimum. My minimum value is occurring there, but I don't know what that is, so I hit second, trace, number 3. Move the calculator around to account for it. Better, go to the right. Better. Let's do this over here for right now. So my minimum value, my vertex, is at negative 0.75 and negative 4 1/4. There's my minimum. There's my vertex. Okay. To calculate the zeros, all I do again, go back to the calculator. Second, calculate 0. I'll take care of the one on the right. Will you guys find the one on the left, please? You guys get the negative 0, I'll get the positive 0. Is that all right? So I have a 0 at 0.686. And then, what'd you guys get over here? Negative
2.18
Yeah, that's what we got earlier. Negative 2.18. Now,
or 19.
is this one going to be okay to be a solid line, or is it supposed to be a dotted line from the curve?
Should be
It's supposed to be solid again. So am I going to include those zeros, or put open holes on them? I'm going to include them. Where is it going to be greater than or above 0?
Negative 2.1 to 0.68.
Going this way, it's always above 0, right? So is our number smaller than negative 2.18 or bigger than negative 2.18?
Small or?
So it's
Negative.
when x is smaller than or equal to
Oh.
negative 2.18, or when x is greater than or equal to 0.686. Those are the values that make the graph positive. When you look at it, the graph
Oh.
is positive all in here, because this is continually upward, upward, upward for all these values. You're looking at the domain that it's giving you a range that's positive, that's greater than 0. And that's all you're looking for. You're trying to find those intercepts. Once you find those intercepts, those zeros of the graph, those are where you decide, is it above or below 0? Okay? Just by doing graphically. Believe it or not, you can do this algebraically as well. Algebraic ones you're going to get, they're going to be a little bit easier to work with because they're going to mainly be factorable. Some of the ones that are graphically, you're going to get crummy looking numbers and decimals and stuff like that. But remember, you're using your calculator, and some of our rounding things, I don't know, see how my minimum was like negative 0.75, and a bunch of zeros and 4? Some of you guys might have negative 0.74999999. You might have to do a little bit of rounding here or there. Okay? It's really not that bad, is it? Oh.
So no homework time.
We got one more. One more stop. Last one. The difference here, it says solve it algebraically. And if it says solve algebraically, all you're going to do is factor and put your numbers on a number line. Let me explain. If I have this same exact problem, x squared plus 2x equals 8, and I have to solve that by factoring, what do you do first? Subtract the 8, so you have x squared plus 2x minus 8 is 0. So what times what is negative 8? You add together, you get positive 2. So it's x plus 4, x minus 2. And then to get your zeros, you set both of those equal to 0, correct? What would be your zeros? Negative 4 and 2. Okay. What changes in this problem? That's the only thing that changes. We do the exact same work. X squared plus 2x minus 8 is less than or equal to 0. X squared, or excuse me, x plus 4, x minus 2, less than or equal to 0. I now set the two terms less than or equal to 0 instead of setting it equal to 0. I set it equal to, or less than or equal to. That's the only change. So now, when I go to solve that, I get values of x that are less than or equal to negative 4, or values of x that are less than or equal to positive 2. Does that make sense? All you're doing algebraically is factoring and setting them up. You set them instead of setting them equal to, you set it to the inequality, and that's how it looks. That one's usually the weirder of them all because it seems too easy. Let me show you one more like that. Same idea. X squared plus 3x minus 18 is greater or equal to 0. I'm going to solve it algebraically. Negative 3 and 6, good. So I have, when I factor that out, I get x plus 6, x minus 3, greater or equal to 0. What are your inequality zeros, if you will, or your inequality values then? Good. So when you write it out as x is greater than or equal to negative 6, x is greater than or equal to 3.
That's all you have to
But you said you put it on number line.
Hey,
You can if you want. Because what happens if you throw it on a number line, you're going to start to see you don't have that overlap. You're at negative 6 and then 3. It's going this way, shaded. They don't overlap until everything is greater than 3. And that's when you know, once you get past this point, that's when that becomes a full true statement.
That's what we're looking at. Yeah.
But so how do you know that it should be, x is greater than or equal to -6 or greater than or equal to 3?
Instead of setting, remember when we had to solve for zeros, we'd set both of these guys equal to 0?
Yes.
The only thing that's changed is we're setting both to
Okay.
greater than or equal to.
Okay, yeah.
Or it would be less than, or it could be a greater than. It could be any one of those four.
Okay.
Does that make sense?
Right here.
Try those, please. You got a couple of each style here.
Oh, man.
You'll be surprised that it winds up being really fast. Make sure you also have the calculators tomorrow. There's a lot of calculator stuff tomorrow. Okay? Systems of equations. Quadratics. Excuse me.
Oh, dear.
Sure. Why not?
We don't have to use like graphics or.
No, rough sketches. Remember, when you're graphing these, I want to you just label where your vertex is and what are your zeros. That's all you got to put on there for me. I'm happy with that. Because that's what you're solving in your calculator. Is it a maximum or is it a minimum? What are your calculate zeros? And you just substitute through and you're going to be good to go. All right?